So I'll not say anything about this particular case because I discussed that before. I'll probably separately record this page for you, for people who didn't attend this class today in live. They will know. Well, let's start with this. So the question in midterm, this is a questions on the first year when I introduced this class in 2018. The names are again just to show that it's different that time. You'll have question type, what we'll discuss now. So there are two type of question where you will have a pictures associated with. You will identify either a specific locations in that pictures to see what are those and what their functions, or you will say, what's their mechanism or how you can improve certain functions. So for instance, here I ask, what are those two functions of those two layers? The next one I ask, how do you increase the contaminant removal in the filter layer? When I say filter layer, you have to look for what is that filter layer. It shows here filter media, that means this could be a filter layer. And then you'll say, for instance, here we can increase organic carbon concentrations. So that will increase Kb, which is F4C times KOC. So Kb means absorption. If the absorption increases, that means you have more contaminant removal. Another way to improve a contaminant is by allowing the contaminant to stay in the filter media a long time. So that's HRT. So your goal is to increase HRT, hydraulic retention time. And hydraulic retention time is basically how long water takes to move through that filter layer. So D by velocity of water. And hydraulic retention time can increase. Either you increase the D, depth of the filter media, means more materials. So that's one way. So that means you can increase HRT if you increase D or decrease velocity of water. Well, how do you increase depth is very easy. You, instead of having 1 feet, you make it 2 feet. Second is increasing or decreasing velocity of water. That's related to hydraulic conductivity, because velocity of water, from Darcy's law, is Ki by porosity. So you can see how you can change those. I is hydraulic gradient, so that's not related to any of the design here. Or it can be designed based on the outlet control. But you can see two factors here. Porosity. If you decrease porosity, you increase velocity. Or decrease, increase velocity. Let's see, if you decrease porosity, you increase let me see, that doesn't, if you decrease porosity, that means you have more interaction, so that should decrease. Yeah, that's right. So if you increase porosity, more porous, water moves much, the water will drain very quickly. So that means you don't have enough time. So that's the, this is velocity of Darcy's by porosity. Okay. So if you decrease the velocity by let's say, if you decrease velocity, means it's moving slow. That means your retention time or contact time is much higher. So that's another way. So you can have smaller size particulates so that it can, particle size is so small that it infiltrates slowly. So these are many different forms of way you can change that. But if you write any of those two, then you will get the answers. Next one is related to redox. That's a chemistry question. You see what's the oxidation state. The following one is, if contaminant concentration in effluent can exceed the influent concentration in biofiltration system, what could be the reason? The question is, usually you have a filtration systems and you have contaminated water coming in, C in, and then your C out is typically should be lower than C in, because your goal is to remove pollutants. But what if C out is greater than C in? What could be the reason? That means your mass balance here is almost, there must be a source here. Okay, source means your bioinfiltration system might be become a source. It happens if you're, let's say for pathogens, if the pathogens are removed but they are growing inside, so that means over time, after a point, even your stormwater is clean, that's coming in, some of those contaminants which are retained can be released. So it could be because of if biofiltration is source. It become a source if contaminant accumulate for so long without being degraded. So you can explain all that. Next one, describe function of different layer. Again, this is a picture, so you can see those are.
Excuse me, Professor?
Yes.
Would you mind explaining part D again? I didn't quite
Okay, so
understand.
the question was if the contaminant concentration in effluents, means what's leaving the system, is more than what is coming into the system, what could be the reason behind that?
Mm-hmm.
Okay. So usually, your any treatment systems filters should remove pollutant. If it doesn't remove, then your influent concentration should be equal to effluent concentrations because nothing is removed. It should not exceed unless there is something in the filter media itself that is releasing pollutant that's not there in the stormwater to begin with.
Mm.
So in that case, your treatment system is a source of pollutant. So that's the reason. So it can happen because if your filter media is already polluted before, and that's now releasing all the pollutants. Or it
Okay.
could be contaminant which are being accumulated and grow. For instance, bacteria, just because you have 10 bacteria coming in, they can stay inside the system and grow to hundreds or thousands. So next time there is a rainfall, the concentration of bacteria is a lot more now because they have been growing inside. So usually this is the case for pathogens, or it is the case for contaminated amendments because it has already pollutant before even stormwater coming in.
So if a pathogen gets stuck in the system, it'll
And
grow
grow.
over time. Okay.
And grow. The condition is for pathogens, they can grow, right?
Mm-hmm.
So chemical pollutant, they will not multiply, right? So that means this is not going to be a problem. I see that anything I type here is not being reflected in the slides. Maybe the computer is frozen, so let me start sharing again.